Parallelograms, just like with the polygons where you're just memorizing kind of formulas, hopefully with a little background so you can kind of remember the formula rather than, just straight memorization. Like 180n minus 2 is because there's n minus 2 triangles in an n-sided polygon. So hopefully we can make some sense of these little characteristics that we're going to be learning. Okay, so parallelograms, what are they? So a parallelogram is a quadrilateral, so a four-sided polygon with both pairs of opposite sides parallel. So if you have a quadrilateral, and this side is parallel to that side, and this side parallel to that side, we call this figure a parallelogram. Okay? So the name is nice, it helps us remember what it is. That's the definition. So if you have to prove something, right, definition of a parallelogram, that would be because you're stating maybe the opposite sides are parallel. Okay. So here's some of the characteristics of parallelograms that you just have to know. You gotta know this. So what are some of them? Two sets of parallel sides, that's the definition. That's easy. What else do you have to know? Two sets of congruent sides. So not only are the sides parallel, this is congruent to that one, and this side is congruent to that one. Opposite sides are congruent, and opposite angles are congruent. Have to know this. They're parallel, they're congruent, opposite angles, congruent. What else? Consecutive angles, remember what consecutive means, one right after the other, are supplementary. That means this one and this one are consecutive angles. Supplementary means what? They both equal, they will add up to 180 degrees. This one and this one, 180 degrees, supplementary. This one and this one, supplementary. This one and this one, supplementary. Opposite angles, congruent. Consecutive angles, supplementary. Diagonals, what's a diagonal, right? That's the two non-consecutive vertices connected. They will bisect each other. So if you draw diagonals, this piece will be congruent to that piece, and this piece here will be congruent to that piece here. That's what bisect means in a parallelogram. Does that mean that all the pieces are congruent? Is this one congruent to that one? Not necessarily. This one and this one congruent, this one and this one congruent. Diagonals form two congruent triangles, meaning that this triangle and this triangle are congruent, and this triangle and this triangle are congruent. And I've got a little, I found this little website. You can kind of play with it. This is a parallelogram. So if I kind of mess with this, AB and CD, AB and CD are congruent. You can see same way. BC and DA, opposite sides, congruent. The angles, opposite angles, wow, that's 180. That's strange, they should be congruent. Opposite angles should be congruent. Now the slopes, why are slopes important? Why are we even talking about slopes? In a parallelogram, why are we even talking about slopes? Yeah? Because they are so parallel. And so what do I know about parallel lines? What do I know about the slopes of parallel lines? They're the same. So that's what this is showing. So if one had to prove perhaps that a figure was a parallelogram, you can show that the opposite sides have the same slope, therefore they would be parallel. So that's what this little figure is just showing us. So many of these characteristics kind of in one picture. So it's a lot of stuff to remember. A lot of different things to remember. Nothing difficult, but just a lot to remember. I like to kind of go through brief little proofs only because it just may help you remember. So real quick, we won't spend a lot of time on them. A quadrilateral is a parallelogram if and only if, so this is a bidirectional, both pairs of its opposite sides are congruent. So if you have a quadrilateral and the opposite sides are congruent, then it's a parallelogram. If you have a parallelogram, then the opposite sides are congruent. Goes both ways. A quadrilateral is parallelogram if and only if, again, biconditional, both of its opposite angles are congruent. So if you have a parallelogram, opposite angles are congruent. If you have a quadrilateral where the opposite angles are congruent, you have a parallelogram. So one way to kind of prove this is, here's my parallelogram. So my definition, opposite sides are parallel. If I draw a diagonal here, PQ is parallel to RS by definition of a parallelogram. You don't have to write this down. Just kind of look. Yeah, if you want. QR is parallel to PS. Same thing, definition of parallelogram. Now, why are these angles congruent? PQS to RSQ. Why are these congruent? And why are these congruent? Why is that? Really? Miss Miss, there? And opposite interior angles of parallel lines. Okay. Why is QS congruent to QS? How come? Good. Right, we do that reflexive theorem of congruence. And so these two triangles are congruent. How come? Why are they congruent? What? What can I do? No, congruence. Think about the congruence theorems. Look what you got here. There you go. Okay. Therefore, PQ is congruent to RS, and QR is congruent to that. That's your CPCTC. Okay. And then you can draw one the other way. You can get everything else. So we can kind of show all these in the here. Right? This one is going to be congruent to that one by CPCTC. So we can prove that. What else? Examples. All right, so what do you do with these? How do you apply these different theorems? Find x and y. I think this one's on here. Yeah. This is example A. It's a parallelogram. How do I know that? Because I see the parallel markers. Therefore, this opposite sides are congruent. So I can quickly solve that, right? Add 1 to both sides. And x is 4. So that finds x. Now y, I also know that opposite angles are congruent, so what's y? Yeah. That one's pretty simple. You're probably going to see more complex expressions there. But that's basically all you're doing. How about this guy? This is example B. How do you know that this is a parallelogram? Oh, it's a good question. Okay, I have one set of opposite angles that are congruent. That's good. But I need two sets. How do I find what this angle is? Tejas, how do I find what this angle is?
If you know it's not a parallelogram.
Well, I don't. Right, I want to show that it's a parallelogram.
Well, if you measure angle Q and angle on, if you add it together, 180.
Okay.
So
Has to be all the consecutive angles, right?
yeah.
I kind of need to find this guy, don't I? Can I? How?
Like when you get diagonal.
Can I do the diagonal? You're making it hard. You're right. We can get it to work, but we have to make it so hard. Yeah, how can I do this, Bruce?
The sum of the interior angles quadrilateral is 360.
Good.
So subtract the other angles from 360.
Right. Yeah, this is a quadrilateral. They all add up to 360. We have that corollary, or you can use 180 and -2. Yes, sir?
I didn't get the final one.
How do you do it?
So I cut the quadrilateral into two triangles. So 113
Here?
divided by yes, I cut it in half there.
Yeah.
113 divided by 2 was
Whoa, let's stop right there. How do I know what bisect is? I don't. And so, yeah, now there are going to be some quadrilaterals, that's true, but it's not necessarily true for a parallelogram that it's going to bisect the angles. What bisects? The actual, what's it called? The diagonals themselves bisect the segment, but we don't know anything about the angles. I think, Grace, this way may be the easiest way to do this. Now, if I solve for x, guess what I get? Anybody do it? Yeah. Okay, now, how can I tell that this is a parallelogram? Congruent, congruent. If opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I'm using kind of a converse of that theorem that we had about the angles. Make sense? So it's easier than you guys thought. You guys are used to thinking like more complex because that's a hard problem. All right, here's another theorem. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Meaning this plus this is 180, this plus this is 180, Add those two, you get 180, add those, you get 180. Any two consecutives will add up to 180, be supplementary. This one I think is a little bit easier to kind of show. So if I kind of extend these lines, here's parallel lines, right? And this could be transversals, and we have a theorem that consecutive angles of a parallel lines are supplementary. So that's all that's going on here. Because everything is parallel, you can think of the other line as the transversal, so they have to be supplementary. So this was kind of, I think, an easier one to see. Yes? Do we agree?
Yeah.
Yes. Okay. How do we prove that these are bisectors? So this one's slightly more interesting, right? So how do we do that one? So if I have a parallelogram here, and here's my diagonals BD and AC, and here's where they intersect. Okay, this is what I'm trying to prove. I don't know this part yet. That's what I'm trying to prove. So let's see. What do I know? I know that AB and DC are congruent because it's a parallelogram, therefore the opposite sides are going to be congruent. I also know that angle ABD, this one, is congruent to CDD. Here's my Z shape. These are alternate interior angles of parallel lines. They must be congruent. I also know that BAC and DCA, that's the kind of the Z going the other way, are also congruent. Therefore, these two triangles, this triangle, ABM, and this triangle, CDM, are congruent by angle, side, angle. I could have done this another way. I could have said, look, there's verticals. Oh God, angle at the side, right? All kinds of different ways. But these two triangles are congruent. So therefore, this one and this one are congruent, and this one and this one by CPC. So that's how I know they bisect each other. So the only reason I'm really spending a lot of time with these is if you forget, you can kind of reprove and refigure out, oh, that's right, yeah, they are, they bisect each other. So examples here, this one is, oh, there it is, yes. It's right under the theorem there. It's the middle of the page one. Find X. Well, what kind of angles are these? Consecutive. What do I know about consecutive angles in a parallelogram? They are supplementary. So 2x plus 42 has to equal 180. Subtract 42 from both sides. Okay. 138. Divide that by 2. 69? That's 69. So that makes supplementary angles. Let's see what we got here. Find A and B. Okay. These look like my diagonals. What they didn't tell us here is that this is a parallelogram, so I will tell you. This is a parallelogram. We kind of need to know that. Oops. And once I know that, that means that these diagonals bisect each other. So this piece is congruent to that piece. So 5A equals 15, which makes A equal to 3. And then this piece will be congruent to that piece. So B minus 1 equals 9. So B equals 10. And then here's another question. This is an example towards the bottom of page 1. So what value of X is quadrilateral CDEF8 parallelogram? So I already know that this piece congruent to that piece, so this is bisected. For it to be a parallelogram, this one would have to be bisected as well. So that means that 5x minus, I think that's an 8. Yep. That 5x minus 8 has to equal this other segment's length of 3x. Subtract 3x and add 8. So what do I get? 2x equals 8. So x equals 4. Questions? Again, there's nothing really terribly difficult. There's just a lot of little things to remember. Alrighty, this is good theorem coming up. I like this theorem. If one pair of opposite sides of a quadrilateral is congruent and parallel, then the quadrilateral is parallelogram. So if I don't know anything about these sides, but I do have that just one set now, I don't have to worry about the other set. If it's both parallel and congruent, you will have a parallelogram. This is kind of a nice little theorem. You tend to forget about it, so you might want to just maybe make a little star, because sometimes it comes in handy, and we tend to forget it. The other ones kind of get in our minds better. If one set congruent and parallel, you have a parallelogram. How come? All right, let's see what's going on here. So I've got a quadrilateral, and I'm given that they're parallel and congruent. So let's see. I've drawn this diagonal here, so I know that this angle and this angle are congruent by alternate interior angles of parallel lines. I also know QS is congruent to itself by the reflexive property. So let's see. I've got a side angle side angle side. These two triangles congruent. So since they're congruent by CPC2C, that means these two sides are congruent. So both sides, opposite sides are congruent. Therefore, it must be a parallelogram. So it's a nifty little theorem to have. You never know when you're going to need it. So it's a good one. Okay, so my example on the bottom of page 1 for this one is for what value of x is quadrilateral FGHJ, right here, a parallelogram. Now all I know is that one set of sides is parallel. I do know that the length of this is 5x plus 2, and this expression describes the length of JH. So if these two were congruent, because they're already parallel, that's enough. So what value of x makes them congruent? I don't know, let's see. So I would set them equal to see what value of x makes them equal. I guess I'll just show you. 4x plus 8. And I subtract 4 and then subtract 2. Looks like x equals 6. Did I answer the question? Yes. Well, what value of x? If one value you get the same congruent value. Alright? So let's just do a real brief summary. Again, lots of little things. So one page here. So if you know it's a parallelogram, here's things that you can conclude. The opposite sides are parallel and the opposite sides are congruent. You can also conclude that the opposite angles are congruent and the consecutive angles are supplementary. You can conclude that diagonals bisect each other and that you get those two congruent triangles, kind of those like opposite triangles, will be congruent. Now let's say you have a quadrilateral and you want to prove that it's a parallelogram. Well, if you can show both sets of sides are parallel, or both sets of sides are congruent, or both sets of angles are congruent, you will have a parallelogram. If you show that that the consecutive angles are supplementary all the way around, then you have a parallelogram. If you can show the diagonals bisect each other, then you have a parallelogram. And then we have that last proof. If you've got one set of sides that are parallel and congruent, you have a parallelogram. So I tried to put that all in one place. Because again, nothing hard, but just a lot of little details. Questions? You ready to give them a try? Yeah? So this is just basically working with those different theorems and properties to figure out these values. So go ahead, give these a try.
So you may have finished these first four. I'll put answers up for that. Check how you get on.
Should I turn the page and put the other answers too? Ready? Come PR? Now I'll scroll back to it. I will. Check these. Wait, let's still check it. It was up with that. Up with that. That's not going to be going to be did I give it two? I think there's a couple more after this. I'm just going to scroll past and put it up, and I'll go back. And some of you actually made it to this. I just want to have them up here for you. And I'll scroll back. You made it all the way to the end. This is what you get. But it's okay. I'm going to scroll back in a second. Let's see. These ones are my equipment geometry questions. How do you do with H? We have to get this. Your basic job here is to kind of plot these, right? So -2, -3, that's A. B would be 1, 2, 3, 4, 1, 2, right? B. 3, 2, 1, 2, 3, 1, 2. And then I don't know D. So if I kind of look at these, oops, I'm a little trouble here. It's here somewhere, right? Somewhere. So what I did to do this, and there's many different ways, I used the theorem that said if it's the same length and parallel, then I know I have a parallelogram. Well, this is a nice horizontal line, right? So to be parallel, I just need another horizontal line. Both have a slope of 0. So that's easy. And then if I can get it the same length, now this one, I just counted boxes, and there's a question about distance formula. But you can use a distance formula, absolutely. Well, for I. For H, I is easy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now I've got opposite sides that are parallel and the same length. And then I just write off what that was. So hopefully that is negative 3, 2 up here. You know, there are other ways to do it. That's how I saw how to do it. Now this one, show that the figure is a parallelogram. Again, you've got all kinds of choices. You can find the slope of all of them and show that they have the same slope all around. So what's the slope of this guy? Let's see, this is positive slope up to, right, oh, this is the slope of 1, right? Let's check the opposite side. Up 1, right 1, up 1, right 1. That also has a slope of 1. What's the slope of this guy? Let's see, down 2, right 1, down 2, right 1. Looks like this is a slope of -2. Does this have a slope of -2? Down 2, right 1, down 2, right 1. So you could do this. You could say, because the opposite sides are parallel lines, they have the same slope, therefore they're parallel. That would be one way. Another way would be to say, well, I'm just going to work with one set of sides, and here's where the distance formula would come in. And I don't know if this was your question, Pages, was, you know, do it for one. Slopes are the same. They're parallel. And then let's see how long they are. So I chose these two. You could have done it equally with the other two. But what's the distance now of KL? What's the length? So I look at the distance between 2 and 4, my x values, that's 2, square it. And then I look at the distance between the y values, that's also 2, square it. That's the distance formula, or basically the Pythagorean theorem. This is, what, 4 times 2, so that's 2 radical 2. And then what's the length of mn? Do the same thing. What's the distance between my x values of 4 and 6? 2, you square it. What's the distance between 0 and -2, my y values? That's also 2. Square it. So I'm getting the same value. So since these are parallel and congruent, I know it's parallelogram. So you can use either one of those theorems. Doesn't matter. So questions? What do you think? We got this.